Okay, hello. We are now in quadratic unit. I think you'll really like this unit. It's one of my favorites. These are your notes. You should have them. Woo. Sorry, the DocuCam's a lot harder because of focusing. Let me turn on a light. Okay. So we're in chapter 4.1, graphing quadratic functions. So you have a on the first page. I want you to complete it, this, and then I'm going to check it in class when you return. Okay. It's just kind of to warm you up for the lesson. So make sure you do that first. So pause the video or stop it until then. The first sentence says a quadratic function is any function that can be written in the form ax squared plus bx plus c. Okay. A can't equal 0 because if a is 0, the x squared part disappears and then it's linear. So just a can't be 0. It says let f of x equal the quantity x minus 3 squared plus 5, show that f represents a quadratic function. Identify a, b, and c when the function is written in standard form. So this form is called vertex form, and we'll talk about that later. This form is called standard form. So just like in chapter 1 where we had slope-intercept form, standard form, point-slope form, there's many forms for quadratics. So if I take this quadratic and simplify it, we are now in standard form. You FOIL the beginning. And you're going to get x squared minus 6x plus 14. Once you've simplified, it's now in standard form, and it says identify a, b, and c. Well, a is 1, b is -6, and c is 14. Okay. It says the graph of a quadratic function is a parabola. Okay, it's that U-shaped curve. Parabolas, okay, can open up or down. They have an axis of symmetry. So these are important things that we're filling in the blank. They have an axis of symmetry that divides the parabola into two parts that are mirror images of each other. If you look at the pictures down here, this is your axis of symmetry. Just like in third grade when you learned about the Earth tilted on an axis, it's the same thing. This cuts it right in half. And it's a line. It's a line that's straight up and down. And when we have a line that's straight up and down, is that an x equals line or a y equals line? Well, there's no slope. So the axis of symmetry is always in the equation of x equals. Okay. It says, what point should you use to graph a parabola? Well, if you look at it, the highest and the lowest points seem very important. So these are key features when graphing. So you should use the vertex. The vertex of a parabola is either the lowest or the highest point on the graph, the maximum or minimum value. So notice the axis of symmetry goes through the vertex. So if we call the vertex HK, instead of XY, we need something different, then H is the X value and K is the Y value. So we call that our vertex, and that way when we have an equation for an axis of symmetry, it literally is x equals whatever h is, okay? I know that might seem a lot, but just take it in for what it is and you'll figure it out as you go. All right, it says example 2. Write the following quadratic in standard form. Then using the graphing calculator, identify where there's a maximum or a minimum. Give the approximate coordinates of the vertex and write the equation in the axis of symmetry. So first of all, make sure it's in standard form, from highest degree to lowest degree. And then you're going to graph this in your graphing calculator. Do you have to know this? No. So do you have to know this? No, but like I said, I remember being in calculus and knowing how to use my calculator, benefited me so much. So if I couldn't remember something, oh, if I just graph it, I can figure it out. So using your resources. So if I hit graph, okay, I want to know what that lowest point is. So I have this like red dot here as a scatter plot. Let's see, let's just get rid of it. Turning my scatter plots off. Okay. Why is it still there? Oh, the other one's on too. Okay, get out of here. All right, so I want to know what this lowest point is. So I'm going to go to second calc, and I'm going to find that lowest point, that minimum. So it says left bound, take your arrow and go to the left. Enough that it's far away. You're telling the calculator bounds that you want to work with, right bounds. So you're like, okay, calculator, between these two areas, what's the lowest point, calculator? And here, calculator says guess. I'm going to guess where it is, calculator. Enter, and it will tell me. Your minimum value is at 0.5, comma, 75. So your min or your vertex is at 0.5, comma, 0.75. Okay? You're going to do the same for the other. You're going to go to y equals -2 x squared minus 6x plus 7. You're going to hit graph. Okay, if your window isn't like this, some people it's cut off, then you need to go to window and you need to make your y values bigger. My y max is 20, usually in a calculator it's 10. Make it bigger so you can see the top. All right, now we're going to go to second calc, which is trace. And you want not a minimum, you want a maximum now. Enter. So when in doubt, to the left, enter, go to the right, just far enough to the right, and then you're going to guess. Third, enter, and it's -1.5, comma 11.5. So that's using the calculator. Oh, it asks you to write also an axis of symmetry. So when we graphed this, what is an axis of symmetry? Well, it goes through 0.5, so x equals 0.5 is the axis of symmetry. Here, it went through -1.5, so your equation is x equals -1.5. And it's x equals because there's no slope, so it wouldn't be y equals. Okay? It says, if it's greater than 0, it's positive and the parabola opens up. The vertex is a minimum. Okay? And the y coordinate then would be the minimum value, the minimum y value. If it's less than 0, it's going to be opening down. Think about it. Negative people frown, positive people open up and smile. The vertex is then a maximum, and the y coordinate, 11.5, will be the maximum value that quadratic will ever have. It's not going to be higher than that. Okay? How do we find the vertex without using a graphing calculator? So here, if we simplify it, like I said, if I go too fast, you can always pause the video, do the work yourself, and come back to it. So here it's in standard form. So when it's in standard form, there is actually an equation you could use. To find the x and y values of the vertex, you're going to use the formula opposite of b over 2a, and then whatever that value is, you're going to plug it back into your function and do the same thing. So my opposite of b is 10, 2 over a, which is 1, and then I'm going to take that and put it in to my function. So it's 5, and then I'm going to put 5 into my function. What do I get? If I put 5 in here, we're going to get 5 squared minus 10 times 5 plus 22. We're going to get 25 minus 50 plus 22. Oops, it's cutting off. Sorry. We're going to get -25 plus 22, which is -23. Now, that seems really intense. -5 plus 25 minus 3. Opposite of b, 10, 5. If I put 5 back in, yeah, it shouldn't be, it's -3. I just didn't do that math right. Okay, so you get -3. So I'm going to put my vertex here in the middle. The vertex is 5, -3, because it's It's the best part of the graph. It's the meat of the graph. You want to make sure you see that U-shaped curve, so you need your vertex. So, oh wait, look. 5, -3. This is in vertex form. You can see the vertex. 5, -3. Okay? So once you get the vertex, you pick a few points to the right and you pick a few points to the left, and then you graph. Well, since these are equidistant apart, they should have the same outputs. So you can use this formula or this formula. If I take 4 and substitute it in here, I get 4 minus 5 squared minus 3. That's going to be -1 squared. 1 minus 3 is -2. It's going to be the same thing here. If I substitute 3 in, I'm going to get -2 squared 4 minus 3, which is 1. I'm going to get, let's make sure, 2 squared 4 minus 3 is 1. Yep. Then you graph. 5, -3, 6, -2, 4, -2, 1, and 1. Okay, and the more coordinates you have, the better. So is there a rule? Is there a textbook that says this is the rule to solving? No. But I say pick a vertex, 2 points to the right, 2 points to the left. If you give me a generic sketch and those coordinates are not right, it is incorrect, because now we're learning how. So that is your lesson for today. What I want you to do now is these 3 questions, pause, do them on your own, and then come back to the video. Oh shoot, bell's gonna ring. All right. So 6, 17, 5, it opens down. Your y coordinate's a maximum. How many x-intercepts can a parabola have? It can have none, 1, or 2. Okay, your homework is the following parabola worksheet and the 4 questions that are after it. We will check our work when we come back to class.